All right, welcome back to our introduction to genetics here, Mendel and the gene idea. So now we're going to move into concept 14.2. Probability laws govern Mendelian inheritance. So, Mendel's law of segregation and independent assortment reflect the rules of probability. When you toss a coin, the outcome of one coin toss has no impact on the outcome of the next toss, right? So one time you flip the coin, you get heads. The fact that you got heads is not going to change the outcome of when you flip the coin again. In the same way, the alleles of one gene segregate into gametes independently of one another. Or independently of other genes' alleles. So this leads us into the laws of probability. So there's something called the multiplication rule, and it states the probability that two or more independent events will occur together is the product of their individual probabilities. So this means that if you have a 50-50 chance of tossing heads, then if your odds of getting two heads in a row are 50% times 50%, which is 1/4. And I'll show you this here in a moment. So this actually works out nicely when we look at Punnett squares. So the probability of an F1 monohybrid cross can be determined utilizing the multiplication rule. So segregation in heterozygous plants is just like flipping a coin. Each gamete has a 50-50 chance of carrying that dominant allele and a 50-50 chance of carrying that recessive allele, right? So let's essentially take coin flips and put them onto a Punnett square. So we are going to flip a coin once and get one value. We are going to flip a coin again and get a different value. So here we have two heterozygote individuals, so big R and little r. And over here, big R, little r. This one is going to contribute an egg, and this one is going to contribute a sperm. It's a coin toss on what you're going to get. So it's 50% of the time it's going to be big R, 50% little r. Same up here. So what are the odds that this coin flip would be a big R and this coin flip would be a big R, right? So what's the odds of being a big R, big R? Well, the multiplication rule tells us that it's this probability times this probability. So 1/2 times 1/2 is 1/4. Same thing is true over here. 1/2 and 1/2 is going to give us 1/4 for this. Notice that this one, while it's still going to be a big R, little r, is getting its big R and little r from different sources. So this one is actually getting big R from sperm and, big R from egg and little r from sperm. Here, this one is getting little r from egg and big R from sperm. So it's different from this one. The overall outcome is going to be the same, but the odds of getting this are still 1/4. And the odds of getting little r is 1/4, 1/2 times 1/2. Now, let's notice here that if you take aside the fact that this little r comes from the egg, and over here this little r comes from the sperm, it's still big R, little r. So if you look at all these probabilities, it seems like there's twice as much possibility of getting big R, little r, because there's two possible ways of getting it. That's where we come into something called the addition rule. So the addition rule states that the probability that any one of two or more exclusive events will occur is calculated by adding together their individual probabilities. So coming back here, the odds of getting big R, little r is going to be 1/4 plus 1/4, which again is going to be 1/2. So you can see here that if you were going to pick one out of the four of these, that it's twice as likely that you are going to pick a big R, little r, because there are two of them. So consequently, 1/4 plus 1/4 is now 1/2, or 2/4. So probability laws govern Mendelian inheritance. We have the multiplication rule that is looking at the probability of getting a head on one coin toss and a head on another coin toss. That is you calculate those results by multiplying the individual probabilities together. We also have the addition rule, in that if we have more than one way of getting at something, so there's two ways of getting at big R, little r, we calculate those odds by taking their individual probabilities and adding them together, right? So the odds of getting this are 1/2, because there are two ways of getting there. So 1/4 plus 1/4. The individual probability of getting this result or this result is still 1/4, because it is 1/2 times 1/2.